In today's video, we're going to be continuing on our discussion about statistics. Today, we're going to start talking about variance, standard deviation, and percentile. But before we get into that discussion, I want to go over what's due over the next week. All Module 6 assignments are due by December 3rd, 2021. To get to those assignments, you go to Modules, Module 6 Statistics and Assignments, and you'll see all of the assignments that are in there. Those are due by next Friday. The next thing you're going to have to do is complete the student survey. That's located in the module sections directly under the module section, and it's the first thing. It's the student surveys. So when we talk about variance and standard deviation, we got to get a few things clear. First thing, variance. That is the average of the squared differences from the mean. So this kind of tells you how far apart the numbers of a data set are. And that's represented by the sigma, which I'm pointing to right now, and then the squared. The standard deviation, on the other hand, is the square root of the variance. And as you can see, it's the square root of the variance, which is sigma squared. We have two data sets that we're going to used to discuss variance and standard deviation so that you can get an idea of what that is. The first data set you see has -5, 0, 5, 10, and 15, and data set 2 has 3, 4, 5, 6, and 7. Now the first thing we're going to do is figure out what the variance is, and I'm going to get the pen. And to find out the variance, the first thing we have to do is figure out what the mean is. And we know that the mean is the sum of all the numbers in a data set divided by the numbers that are in the data set. For data set 1, we have a -5 plus 0 plus 5 plus 10 plus 15. That gives us a total of 25. We divide that by 5 because we have 5 numbers in that data set. The mean for data set 1 is 5. I'm going to go ahead and put that in here. So the mean for that one is 5. And we're going to figure out the mean for data set 2. We're going to do the same thing. We're going to add all of the numbers, 3 plus 4 plus 5 plus 6 plus 7. That equals 25. And we're going to divide that by 5. That gives us a mean of 5 for the data set 2. Now, just based off of the numbers, although the mean is the same, we can see that in data set 1, that the numbers are a little bit more diverse or dispersed. We have the range goes from -5 to 15, where their range would be +5, 15. So the range of the numbers, it goes 20. And the way that you find out that range is, and I'm going to put it in here. The range is calculated by taking the smallest number and subtracting it by the largest number. Or we take the largest number and subtracting it by the smallest number. For data set 1, we have 15 as the largest number, minus 5. And that would give us, and let me write down what we're doing. Range, data set 1. And if we subtracted 15 minus a -5, that gives us 20. Make that a little bit larger so we can get that 0 in there. So the range for data set 1 is 20. The range for data set 2 . That's equal to 7 minus 3, and that equals 4. Again, what this range is telling me that the data set 1 numbers are farther apart from the mean than data set 2 numbers, because the range for data set 1 is 20, where the range for data set 2 is 4. So they're further apart in data set 1 versus data set 2. Now, to get the variance for data set 1, what we need to do is take the data set number and subtract that from the mean. And for data set 1, we're going to take the first number, which is -5, and we're going to subtract that from the mean, which is 5, and that has to be squared, plus the second number, which is 0, and I might not have enough space to do this, so I might have to go into Excel. It looks like I'm going to run out of space, and that'll be squared, plus the next data set number, which is 5, minus the mean, which is 5, and that's squared, plus the next number, which is 10, minus 5, and that's in parentheses, and then plus the next number, which is 15, minus the mean, and that would be squared. And then all of that would be divided by 5. So we're working on data set 1's variance. Let me open up the calculator. And the reason why we have that squared, we square that, is to make that number positive. All right, so we have the -5 minus 5 equals a -10. But once you square that, so you multiply it by itself, it's 10. So it would be a positive. It's actually going to be a positive 10 or a positive 100. What I'm going to do is I am going to erase the numbers as I square them so that we have enough space. So I'm going to erase this -5 minus 5 squared, because that's the first number we did, and I'm just going to put a 10 there. Or not a 10, excuse me, a 100. So we know that that's 100, and this might get too messy. I'm going to have to use Excel. Make it a little neater, hopefully. I'm going to make this black pencil. So what I did was I just copied the numbers over from this PowerPoint presentation to give myself a little bit more room. I'm going to erase these numbers here, try to make it a little bit more understanding. All right. So again, we have the first one, which is 5 minus 5. So if we clear everything up, we do a -5, which is the first data set number here. And we subtract it by the mean, which is 5. That gives us a 10. When we square that, that gives us 100. So I use the XY in the scientific calculator. If you're using the standard calculator, just click the little 3 lines and select scientific, and that allows you to do the exponent. All right, so we know the first number is going to be 100 plus 0 minus 5. That gives us a -5, but we have to square that, which gives us 25 plus 5 minus 5. 5 minus 5. And if we square 0, it stays 0. That gives us 0. And what's the next number? Okay, 10 minus 5. 10 minus 5 equals that. And then we square that. That gives us another 25 plus 15 minus 5. 15 minus 5. And we square that. That gives us 100. All right, so we have to add all of these numbers up, and then we have to kind of like get the average or the mean of that. Just like we do with the mean, we just divide it by the number of numbers that we have. And I am going to move this down because we're just working with this. So all of the numbers that we subtracted from the mean above, all of those have to get divided by 1, 2, 3, 4, 5. So we divide that by 5, and then that number will equal 100 plus 25 plus 0 plus 25 plus 100, and that equals 250. So the 250 goes in the numerator, and we have the 5 in the denominator because that's how many numbers we're using. And 250 divided by 5 should be 50. 50. Now what that tells me is that's the measure of dispersion or between each data point. The data set 1, the variance for data set 1 is 50. And I need to change that back to that. Now we're going to calculate the variance for data set 2. And I'm going to use the same method that I did for data set 1, where I add or subtract whatever the number is minus the mean. And we know the mean for data set 2 is 5. And I'm going to change this to 2. And I need to be able to see those data set numbers. So again, I'm going to take the number for data set 2. We're going to do 3 minus 5 because that's the mean. That's going to be squared plus 4 minus 5 squared plus 5 minus 5 squared plus 6 minus 5 squared plus 7 minus 5 squared. And we're going to break that down. I'm going to go into the calculator. And again, I'm using the scientific calculator. 3 minus 5 equals negative 2. 2 squared equals 4. So it's 4 plus 4 minus 5 equals negative 1. We square that negative 1 to make it a positive 1. Plus 5 minus 5 equals 0, and 0 squared is just 0. Plus 6 minus 5 equals 1. We square the 1. 2. So that's 1 plus 7 minus 5. And we square the 2. That gives us 4. Then we add all of these numbers together, and since we're adding, we're going to get kind of like the mean for this. And we need to put a 5 down here because there's 5 numbers that we're about to add. 4 plus 1 plus 0 plus 1 plus 4 equals 10. Let me go over here, put my 10. So that equals 10 over 5. And 10 divided by 5 is 2. The variance for the data set 2 is 2. If we have our variance, we can easily come up with the square root or the standard deviation. To come up with the standard deviation for the data set 1 number, we just take the square root, and I'm actually going to draw that in there, the square root of 50. That's equal to 25 times 2. And it would end up being 5 square root 2. I put the 5 square root 2, which is the standard deviation for data set 1 here. I need a little bit more room to work on data set 2. What I'm going to do is just go into Excel again. That way, and actually I won't have to do that because the square root of 2 is equal to the square root of 2. We can turn these two numbers, the square roots of 50 and the square root of 2, into whole numbers by using the scientific calculator again. Let me move this over here so that we can see. So if I wanted to just use the calculator and get the square root of 50 or 5 square root of 2, we just put 50 in here and use the square root function in the calculator. And that gives us a number of 7.07. And for the square root of 2, I'll put 2 and then use the square root function, 1.41. So it can be written different ways. We could have just kept it square root of 50, but we were going to break it down, which that goes to that. And then the square root of 2 is just pretty much that. Just another way of finding out the square root. I just wanted to give you the behind the scenes before you just start putting it into the calculator and trying to figure out the square root and what the variance and the standard deviation were. How are we going to use this in statistics? We have to figure out percentile before we move on to our next thing. We know about the variance, we know about the mean, we know about standard deviation. Now we're going to talk about the percentile. The percentile is the percentage of data that is at or below a specific point. For this example that we have right here, which of the following is the closest estimate to the percentile rank for a student that studies, let's just say studies. Let me change that right now. That studies 5 hours each day. We have an option of A, 40th percentile, B, 50th percentile, C, 70th percentile, and D, 85th percentile. Now remember, we're trying to figure out all of the data that's at or below a specific point. Our specific point is going to be this 5-hour study time. And everything to the left of the 5-hour is what we need to calculate. But before we even do that, we need to figure out how many data points we have in here that we're going to be using. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we're going to turn this into a fraction to find out what the percentile is. The denominator is going to be the 14. The numerator is everything that's at the data point and below. And since we're trying to figure out 5 hours or below, we just count the number of instances where students study. So we have 1, 2, 3, 4, 5, 6, 7. We have 7 students at 5 hours or below. And just based off of that, we can break that down to 1/2, or you can go into your scientific calculator and turn this into a decimal, which you take 7, the numerator, divided by the denominator, 14, which gives us a 0.5. And we know the percentage, making a decimal into a percentage, pretty much it's 50%. And since we know that that's 50%, it would be, our answer is going to be the 50th percentile. So that's how you figure out what the percentile is. And just remember, the percentile is the percentage of data that is at or below a specific amount. So if we decided to say 6 hours was our threshold, then we would include the student or the data point for the 6 hour and everything below that. So instead of 7/14, we will have 8/14. If we divided 8 divided by 14, 57th percentile. So that's how you figure out the percentile. Now, how does that play into normal distribution, which we use a lot of? The normal distribution, when we're talking about that, and I'll draw a curve very soon. Let me give myself a little bit more space here. Hopefully we'll have enough space. Now with the normal distribution curve, let's draw. You have a line, and when you have a normal distribution, anything in the middle, that's 0. And then you have your bell curve. Anything to the right of the 0 has 50% of the area, and anything to the left of the bell curve also has 50%, because this is a normal bell curve where you have an equal amount of data on each side. We're going to use our knowledge of variance, standard deviation, fractions to figure out this problem here. Final exam scores in a math class were normally distributed. Again, we'll put our bell curve down here. So we have our bell curve. We'll make it a little bit longer. When we have 0 in the middle, oh, that's terrible. 0 in the middle, and we know that 50% over here and 50% over here, because it says it's normally distributed with a mean of 65 and standard deviation of 5. We need to find, and let me type in what A, B, and C are, because we want to find out the scores for the different percentiles. So I'm going to type that in, and then we'll figure out what the answers are. Now to find the 97th percentile, the 90th percentile, and the 25th percentile. Remember, the percentile is the percentage of data that is at or below a specific amount. But we need to find out what the score is based off of, we have the mean, the standard deviation, and the percentile. To do that, we're going to use this equation here, which is for normal distribution equation. And we have Z equals X minus mu over sigma. And we know that sigma That's the standard deviation. Mu is another way of saying mean. And Z, the Z table that we're going to use, the Z is the area of the curve. The X is the unknown value. So we're going to use this equation to find out what the score is at the 97.5th percentile. And let me think, should I use, yeah, I'm going to use Microsoft Excel to do that. Just want to make this a little bit smaller so we can see it as I'm, let's see, is there anything over there? Nope, we have everything we need right here. And let's scroll up and we're going to get rid of our variance. And let's go back to our pen. So we're going to use Z, and when we use the Z, we have to use a specific table. First thing we want to do is draw our distribution table. So I'm just going to write a 1 here. I'm going to do it by steps so you understand. So we have our distribution table. It says it's normally distributed. Oh, that is terrible. Hold on, let me erase that. I'm going to make it look a little bit better. Let's move it right here. So we have our distribution table, and we know when we have a normal distribution table, 0 is in the middle. And we have the little bell curve. So it wants us to figure out everything to the left of the 97.5th percentile. So we know that 50% is on the left, 50% is on the right. So we're going to put 97.5 right here. So this is the 97.5th percentile. Just note that says percentile right there. My handwriting's terrible. So we need to find out what that score is to the left of there. And the next thing we're going to do is we're going to use our equation. Let's go down here. We'll put a 2 here. We know that Z equals X, the unknown value, minus mu. We know what the mu is. And all of that is divided by sigma. That looks like a 6. Let's change that to sigma. And we know that that's standard deviation. So let's start plugging in the numbers that we know offhand. I'm going to move down here. We have Z. I'm not going to put anything in the Z, but because we're going to find out what the Z is. We know that the standard deviation is 5. And we know that the mean is 65. We don't know what the X is. That's the unknown. To get the Z, we need to go into a table. Now, there's 2 different tables that you use, depending on whether it's on the right-hand side of the mean or the left-hand side of the mean. We know that 97.5 is on the right-hand side of the mean, so we're going to use a positive Z table. We're going to use this. And what we need to do is find 0.975 because 97.5%, you just break that down, move this down, 97.5% is the same as saying 0.9750. We need to find this value, 0.975 value on this table. And in order to do that, we want to go to, there it is right there, 0.975. So that's the area of the table that we're going to be talking about. And we just use this number, 1.9 and 6. So the Z is going to be 1.9 1.96. That's how we found the z number. We looked into our positive z-scores, which is the positive, that's the right-hand side of the mean, and we found this 97.5 as a decimal on here on this table, and it comes out to be 1.96. So I'm going to move down a little bit. All right, and we're going to do 3. We have 1.96, and before I even go down that far, we're going to simplify. We're going to get rid of the 5 at the bottom, and to do that, we need to multiply 5 on each side. So on the right-hand side, this 5 cancels out that 5. On the left-hand side, we need to multiply 5 times 1.96. So I'm going to go down to step 3, and we have 5 times 1.96 equals x minus 65. Now I want to shift everything from the side where x is. So to do that, I'm going to add 65 on each side plus 65. And this cancels that out. And I'm going to go down to the 4th step, which x is equal to 5 times 1.96 plus 65. And that equals, let me get into the calculator, 5 times 1.96, that equals 9.8 plus 65 and plus 65. So the score in the 97.5th percentile is 74.8. So I'm going to go in here and I'm going to go ahead and type the answer, 74.8. Now the next one, let me erase this. It might be kind of confusing down there. Now for the 90th percentile, we're going to pretty much follow the same procedures. Let me go ahead and erase this, and then we'll figure out the 90th percentile. Now we're ready to work on the 90th percentile. So we're going to follow the same steps. We're just using the different percentage. We're going to start off by drawing our normal distribution curve. And we know that that's a bell curve. We know that 50% to the right, and then there's 50% to the left, or 0.50. But we want to know the 90th. We know that this is the mean is always 0 when we're doing a normal distribution curve. So 90 or 0.9 is probably going to be here. So 0.90 or 90th percentile. Now the next thing we want to do is look at our equation, see what we have. We know that we're going to have the z number very shortly. So we'll just use equal, x is the unknown value, which is the score we're trying to get. The mu, again, that's 65, that's the mean. All of that is divided by 5, which is the standard deviation. And to find the z value, which is the area of the curve, we need to go into, again, since this is on the right-hand side of the mean, we're going to use the positive scores, positive z-scores. And what we're going to have to do is find 90% or 0.90 or something close to it. So it looks like right here. So for my class, you want to use the number that's closest to 0.90. We know that 0.9015 is 15 away, and 0.0997 is only 3 away. And the way I'm doing that is I'm just subtracting 0.900. I'm subtracting 0.8997 from 0.9000, and I'll put that in the calculator just in case you don't understand. So what I'm doing, I'm taking 0.900 because that's the 90th percentile, and I'm subtracting it by 0.8997 because that's what's in the table. So I see that that's 0.0003. And if I did the same thing for 0.905, 0.9015 minus 0.90, and that shows me that it's 0.15. So this number is a little bit further than this 8997. That's the number we're going to use. We're going to use the 0.8997 for the Z number here. So 0.8997. And we're just pretty much going to follow the same steps that we did before. We know that we want to get that 5, get rid of that 5. So we want to multiply this side of the equal sign by 5 and this side of the equal sign times 5. So on the right hand side, that cancels out. Those 5s cancels out. On the left hand side, we're going to just multiply that a little bit further down. So that gives us 5 times point. Oh, shoot. It's not. Sorry. Let me get rid of that. We need to get that Z value. I forgot to write the Z value down for that. Where is it? So it's 1.28. So the Z is actually 1.28. Yeah. And again, I found the number that's closest to that 90%. And then I use the 1.2 and then 8 there. So it's this number right here, which I can circle it. It's this number right here is what the 90 percentile goes to. So now let's go to step 3, and we're going to use 1.28 equals x minus 65, and we want to move the 65 over from the right hand side to the left hand side. To do that, I'm going to add 65 on this side and then plus 65 on this side. So on this side, those two cancel each other out. And on the left hand side, that just gives me 5 times 1.28 plus 65. So I'm going to move down to step 4. X equals 5 times 1.28 plus 65. If I go into the calculator, calculate what 5 times 1.28 equals. That's 6.4. So we're going to take it down a step further. X equals 6.4 plus 65. And to find what X is, or what the score is, we're just going to add 6.4 plus 65. So we already have 6.4 in here, so I'm going to add 65 here. And that gives me 71.4. So the 90th percentile, the score, move this over. The 90th percentile is 71.4. Let me erase everything in Excel so I can start working on the 25th percentile. Okay, find the exam score in math class. In a math class, we're normally distributed with a mean of 65 and standard deviation of 5. We need to find the 25th percentile. So the first thing I do whenever I'm doing these problems, again, I'm going to draw my normal distribution curve. And we know that for the distribution curves, 0 is always the mean or in the middle. And know that it's going to be like that. And we know that 50% is on the left-hand side, 50% on the right-hand side. But for this one, we're going to be finding it for the 25th percentile. So instead of it being on the right-hand side, like it was for the 97.5 and the 91 percentile, we're doing it on the left-hand side because 25 would be somewhere, we'll just guesstimate that it's right here, percentile. So we're going to draw our little dots. And we're going to be trying to find something which is on the left-hand side. So next, we're going to start plugging our numbers into our equation. We know we're going to find the z. We're going to use the z table, which is the area of the curve. X is the unknown because we're trying to find the score. The mean is 65, and the standard deviation is 5. So that's where I'm getting these numbers from again. Now we need to go into our z table. So since it's on the left-hand side of the mean, which is always 0 when we're doing a normal distribution, we need to use a negative z-score table. This is the positive z-score table, which has all that shaded in. The negative z-score table has just a little less shaded in here. So we're going to do the same thing. We want to know the 25 percentile. And we know that 25% is 0.25. We need to go into our negative z-score table and try to find 0.25. Again, it's not exactly the same, but between 0.7 and 0.07 and 0.08. So I'm going to figure out which one is the closest to 0.25 by subtracting the numbers. The first one we're going to do is this one. So 0.2514 minus 0.25, which is 25 percentile. We know that that's 0.0014 away. And then the next one is 0.2483. Well, actually, we need to put the 0.25 minus 0.2483. That's 17 away. So again, this one's closer, this 0.215. So our number is going to be a negative 0.67. So our z number is negative 0.67. And we are going to start getting our equation together. We want to get rid of this denominator. We're going to multiply all of the numbers to the right of the equal sign by 5 and all the numbers to the left by 5. And on the right, that cancels that number out. And then on the left, that leaves us with 5 times negative 0.67 equals x minus 65. All right, so we're going to move down to step 3, which is getting x on the side by itself. And in order to get x on the side by itself, we add 65 to each side. So the left side of the equal sign, and minus or add 65 on the right-hand side of the equal sign. And we know that negative 65 and 65 cancel each other out, which leaves us with, I'm going to put my x on the left-hand side, x equals 5 times negative 0.67 plus 65. And if we put that in our calculator, 5 times 0.67, which is a negative. That gives us negative, and let me go to x is equal to negative 3.35 plus 65, and this is step 4 here. We'll just make that a step 4. And we know that step 5, x is equal to, so we have our negative 3.35 here. We're just going to add up 65 here. 61.65. That would be the score for the 25th percentile. 61.65. That takes care of all three of those. Oh, let me get there. So remember, when you're doing a normal distribution and trying to figure that out by trying to figure out the scores or trying to figure out something, and you have a percentile and you have the mean and the standard deviation, all you need to do is figure out what x is, and you can find out what x is by using this equation. The z equals x minus mu, which is the mean, all divided by the standard deviation, or sigma. And that's how you use the z table in this equation to find out different numbers that you need to have. Last thing you have to do, again, this is done every week. You write in your journal entry what you learned. If there's anything you need me to review in next week's class, you put that in there, and it has to be at least 50 words. And in the subject line, you want to put MATH201, whatever today's date is, and then journal entry.